Okay, so here are all the examples graphed. So this is the first example of f of x. We could clearly see that it is symmetric, and that if we took negative f of x with negative x, we would have x to the power of negative x times 6. Honestly, let's just do this quick. And just put negative in front of all the x's. I can't believe I messed that up. Kinda sad. Okay, let's go. I guess it doesn't like that. We see that they are the exact same function, therefore this is an even function. Let's continue with example G. This is G. We see that it looks pretty odd. It has a little squiggle in the middle. So again, let's do the same thing. If it's odd, then it should be the same for negative x. Damn. Negative. And then negative. There you go. And then we need negative g of x. So let's post that in. There you go. So let's compare these two. We can see they're the exact one, therefore this one has to be odd. Let's continue onward. We have h of x, which looks like this. It's a really big boy, so you could tell. So let's zoom back in. We could see that it has a square and then a cube, but we should still try both of the tests. So the first one, this is f of x. Then we have f of negative x. And then negative f of x. We see that all three of them are different, therefore this function is neither. For part B, we had to figure out whether or not they have point symmetry, line symmetry, or none. So let's do that quickly. Here, again, we just do the tests of whether or not it is odd or even. So let's do that. Negative x. I think I could just do that. Maybe? No. There you go. Negative x, f of x, the exact same function. Therefore, this is even. And as you can see here, it is perfectly symmetric about the y-axis. However, let's look at G now. G, we see it's a little squiggle. So we have to prove that it is an odd function first. So let's do that quickly. Negative. Come on. And then last one. Well, we know this is going to be a positive. There you go. This is with g of negative x. Now let's do negative g of x. What do we get? We get that these two are the exact same function. Therefore, this is an odd function, and it has point symmetry around the origin. We see this part equals that part, and so we're really happy with that. Lastly, we have h of x. This is what it looks like. So let's figure out whether or not it is symmetric. We have negative x and this one is going to be a plus, and then we need to do the negative, and then just, well, we could see h of x. So from here we see that again none of them are the exact same, therefore it is not symmetric around the origin, and it is not a odd or even function. And that's about it for this part.